Hi everyone, so I'm Mike Giambalvo. I work at Google on Google Cloud Platform. Actually, I work on the UI for Google Cloud Platform, which is the biggest Angular app within Google. So we're going to be talking today about change detection in both Angular and AngularJS. So what is change detection? So this is a common feature that every JavaScript framework has. And this is when the app decides to look at the changes that have happened in your model, in your JavaScript code, and then render those changes to an updated DOM, to an updated browser representation. And an important thing to keep in mind is that DOM updates are one of the most expensive things that a JavaScript app can do. You can trigger a style change, which basically has to reflow the entire app. But even just like adding and removing elements to the DOM can be potentially very expensive. So it's one of the biggest value adds of these different frameworks is that they handle manipulating the DOM for you, so you don't have to worry about it. And every JavaScript framework has its own different answer to this problem of taking a change in your application state and then representing it in HTML. There's a really great blog post about change detection in JavaScript frameworks. It's linked off the slides. But basically, this is the sort of way we're going to think about it for the rest of this talk. Is you've got your model on one side, which is just a bunch of JavaScript objects that are all connected in some way, and then a DOM representation of that application state. So in the olden days, in like Backbone.js, jQuery, you would just manually update, right? You would register an event handler, and you would manually add and remove elements to the DOM. Everyone's pretty familiar with this. It's just sort of like the most basic thing. But if you want a more complex application, suddenly you want something else to handle that for you. The way AngularJS or Angular 1.x handles this is with the digest. And the idea behind the digest is we have no idea what may have changed. So we'll just check everything that could possibly need to update. So in your AngularJS application, the model of your application is a graph, right? Things may depend on each other and influence each other. And it's not necessarily a tree, meaning there can be cycles in it, right? And this is sort of a picture of what happens. So you have watch expressions that connect elements of the DOM to your model. Angular has this concept of a digest cycle. So every time you do something that could need to propagate to a change in HTML, you call this digest cycle that runs all the watchers, all the watch expressions, sees that their output value has changed, and if it has, then it runs their apply function. This can cause anything in your application to change. So it has to run the watchers again. And this is how we get that loop on the right. That's the digest cycle, is we run all the watch expressions, we run the updates that are relevant, and then we keep doing that until it stabilizes. And this actually, in AngularJS, there's a limit here. It'll go until up to 10 times. So either everything kind of settles down, or it just gives up, because it's really expensive to just keep doing this checking over and over. So this is kind of a picture of what that looks like, right? So our DOM hierarchy, our HTML page, is connected to our application via these watch expressions. And the watchers fire. They check the model to see if any values in the model have changed. And then in that red one, we see that its watch expression has changed. So then we update its relevant place in the DOM hierarchy. The way React handles change detection is with a virtual DOM. So the idea behind the virtual DOM is, I have no idea what changed, so you just re-render everything and see what's different now. There's like lag in the slides. OK, there we go. So React renders the entire UI to HTML. Now, this would be expensive if we're actually rendering it to HTML, but it's not. It's rendering everything to a virtual DOM, which is just an in-memory representation of what the DOM is going to look like. So every time your application state changes, React is actually rendering a new virtual DOM. And then it compares the two virtual DOMs to see if it needs to actually do the expensive update to the HTML page. So this is kind of what that looks like. You have your model here, and it's just getting like projected onto this virtual DOM that is an in-memory, kind of fast, easy to create proxy for the real DOM. If there's a change in my model, the virtual DOM is going to change. So I re-render everything to memory. I get two virtual DOMs, and then I diff them to see how they, what's changed. And this creates a patch that I then apply to the actual HTML. So this is how React keeps you from doing expensive DOM updates, right? Does it to memory, compares a virtual DOM in memory, and then only propagates the things that have actually changed into the real DOM. So how is Angular different? How does Angular solve this? Angular knows exactly when to check for changes, because it knows when something might have occurred in your application that could cause a need to update. And it knows exactly what should be re-rendered. The way Angular knows what to re-render is with template binding. So in your components, in your Angular app, you're creating template expressions that are binding some value into the DOM. So every component in Angular has its own change detector that knows these are the expressions that I render to HTML. And this is what I need to check to see for differences to update the HTML. So if you've done an Angular application, you know what that looks like, right? These are template bindings. So in this case, Angular knows the contact card component has its own change detector that knows that if name or email change, then it needs to update that template, right? And update that point of the DOM. So that's, so every component in Angular has a change detector. Unlike AngularJS, where you have this digest cycle with loops, Angular only does one passive change detection. So remember, in Angular, your application is a tree of components. So what it can do is it can run change detection on the root component, and that'll propagate down the tree, and it'll only run once. So this actually makes it much faster than AngularJS, which might do a cycle multiple times. And again, there's a good blog post linked in the slides here, Angular 2 change detection explained.
Why is it that AngularJS has to run the digest cycle multiple times?
So this picture is actually a great example of that. So in AngularJS, your model, your changes may propagate both backwards and forwards, and anywhere in the graph of dependencies in your application, right? But in Angular, it's a directed acyclic graph. It's a tree. So changes only propagate down and out to the leaves. So on the left in AngularJS, that top node might change something that changes something in the lower node that changes something back in the parent, and over every turn of the digest cycle. And then you have an infinite loop, but Angular just cuts those off at 10 cycles. And that's why you can write AngularJS apps. They don't just churn JavaScript constantly. So this is the Angular change detection cycle, right, on the right, just going down the tree, through the tree of components. So how does Angular know when to trigger this? Well, what are the things that can actually cause the need to render a change in our application? Events, like scrolling or click events, XHR calls, so doing network traffic and getting the results of a network call. When timers fire, you might have a timer set for a second and you need to do some update. So basically, any asynchronous call that you might do means you need to trigger change detection. Angular uses a tool called ZoneJS, which sort of patches everything that can do an asynchronous call in the browser, which is crazy when you think about it, but they do that. So that whenever your application makes any asynchronous call at all, Angular knows that you've done that, and that when that callback fires, it needs to run change detection. And if you're interested in the actual mechanism for this, it's called applicationref.tick. So there's a thing in Angular that's called the application ref. It's sort of the reference to the top level component in your application. So whatever component you bootstrap your application with, application ref knows about that. And when you call tick on it, it runs change detection in that root component, which then cascades down the entire tree so that every component gets change detection run on it. So sort of a picture of that, right? This is the tree of components. That's your Angular application. Every one of these is a component, and every component has its own change detector that sort of runs independently. This is kind of a picture of how zones work. So every one of those like vertical lines is called a microtask. Think of that as a synchronous bit of JavaScript that's running. So some of them might be longer or shorter than others, right? Depending on the code. But it's a single synchronous bit of JavaScript. The JavaScript VM runs. It runs all these little synchronous chunks of JavaScript. And then when it's done, it goes back to the browser. And the browser takes control. It does network requests. It does event handling. It does rendering. And then if there's something that your application needs to be notified of, it gives you a callback. So the thing that Zones is doing is it's sort of coloring these tasks as belonging to different zones. So the tasks in green are associated with your Angular application. And every one of these, whenever one of these tasks runs or triggers another task, Angular knows to run change detection. But the zones in red, the tasks in red, are run outside of this Angular zone. And Angular knows, well, this isn't part of your application. It can ignore it. It doesn't have to run change detection after it. So, so for example, this might be like a timer, right? Or this might be an XHR call that this thing triggers an XHR that comes back here. And because they're part of the same zone, Angular knows I didn't run change detection for this one. I don't have to run it for this one either. But when something in the green zone comes back, I know I have to run change detection after that. So Zone.js is a sort of complicated topic. That's just a short intro to it. But it's a very useful tool, especially if you want to keep track of asynchronous behavior. In fact, in GCP, we use it to sort of time how long it takes a page to load, because we can track all the asynchronous tasks that get started from a page load. So it's something that's worth learning about. And Angular is just one thing that uses it, but you could use it for yourself too. All right, so ng upgrade. There's two flavors of ng upgrade. One is upgrade module. So this is the standard thing that you've probably seen before if you've looked at running an ng upgrade app. And what ng upgrade does is it intertwines the change detection of AngularJS and Angular. So what that does is when you downgrade a component in Angular to AngularJS, those components register scope watchers. So they know when the digest cycle fires, and when the digest cycle fires, they trigger their change detection. So it ties in your Angular components into the AngularJS digest loop. And every one of those loops, it'll run change detection on your Angular 2 plus components. The upgrade module also will call root scope digest after every turn of the Angular zone. So what that means is in your Angular app, you're doing change detection with every turn of the Angular zone. In upgrade, you're calling root scope digest. So that 10-cycle like circular loop of watch expressions running. That's running every time you do an asynchronous callback. You do a click handler or a scroll event or a network request. So it's a very easy way to do things because it basically means you don't miss changes, right? Like the problem with change detection is you don't want to have some state in your application change and then have it not reflected in the browser, right? You want to make sure that everything ends up propagating through. And this is basically just taking the two differences between AngularJS and Angular 2 and combining them and just run and doing the least common denominator thing of both running with every asynchronous task, but then also running a full digest cycle. So as you can imagine, that's expensive, right? The actual digest cycle is much more expensive than Angular change detection. And it can run up to 10 times. So if you're running this with every async call, it can actually start to slow your application down. And in Jens's talk about upgrade, he's going to go over some ways to work around that. So we had this problem with the upgrade module at Google when GCP started to upgrade. And the way we worked around it was with a new type of upgrade called downgrade module. So in this kind of a way of doing upgrade, your AngularJS and your Angular portions of your app are completely separate. Their changes don't trigger each other. This is brand new in Angular 5. In fact, there are no docs about it yet. There's a PR with the documentation about this feature that has not landed yet. So this is like brand new stuff. The nice thing about using downgrade module is your app is just an AngularJS app. You don't have to bootstrap it any differently. It stays exactly the same. as it did before you upgraded. But you can use Angular 2 components in your AngularJS app. And the AngularJS part of your app, with the scope and all that, will live separately from the Angular 2 components in your app. So if your Angular components need to trigger a digest cycle, they can just do that like they did before by calling scope apply, right? You might have done this if you're doing AngularJS development. If you need to trigger a digest, that's just how you do it. And then in Downgrade Module, AngularJS, the digest cycle will actually still trigger change detection, but you can turn that off if it's causing a problem for you. So if you want to, you can make them totally separate. And this was actually a great fix for us. It fixed all of our performance issues. And the reason we can do this is because when we upgrade, we only have Angular components, right? So our app is an AngularJS app. And if anything is Angular 2, it does not have AngularJS components within it. It's all Angular 2 all the way down. And as long as you're doing that, then you can just have a single Angular 2 module that you downgrade all at once and keep those two parts of your app separate. Other kind of advanced change detection tricks you can use on push. So your components all have their own change detector, and you can modify how it works. And so the most common way you can do that is change the change detection strategy to on push. So what this does is instead of checking all the properties of your component, it only does change detection when at inputs change. And the important thing about this is it doesn't do a deep inspection. It only checks the reference. So if you had like an object that you mutated, it wouldn't pick up on that. You would have to actually replace the object with a new one. So this on push works very well with immutable.js or immutable data structures in general. And the nice thing about this is that now you're saying, I don't need to run change detection on my entire tree. I can only run it for things that might have been affected. So you're sort of like cutting the tree of change detection down to just the bits that you care about. You can even take this further. So here's an example of using change detection strategy on push. And on the right, this is like a simple messaging app, right? It displays a message here and a timestamp. So someone says, I can't wait to eat all these pretzels. And then like a few minutes later, the pretzels are making them thirsty, right? So we only want to run change detection when we get a new message. We don't necessarily want to run it all the time. And the way you do that is you can use change detection on push, right? So this will only run change detection if update changes. Update is an observable. So this observable object will not actually change. It'll just publish new events. And we subscribe to it on an init. And every new message, we update the message and the timestamp. And then we can use dependency injection to get a reference to our component's change detector and mark our component as dirty. So now we're this is like totally taking control of change detection. Nothing is happening for you automatically. You're subscribing to a message stream. And with every new update, you're telling the change detector, hey, check me for changes. And the important thing is because change detection starts at the root and proceeds down the tree, this is effectively marking a path through the tree as needing change detection. So now you've cut it down to the minimal amount of changes, right? This leaf node is your message updater component, and it marks itself as dirty. And the only thing that runs change detection is the path leading to that one dirty component. So if you're finding your app being slow, these are just some of the strategies you can use to make change detection much faster. So that's all I've got. I just added a link to the slides at the bottom after the last presentation. Thank you for highlighting that. So yeah, the blog post that all these diagrams came from, Angular 2 change detection explained. This is a narwhal.io post from Victor Savkin describing how change detection works in Angular 2. A lot of these concepts became the NGRX store library. So you can actually use these pretty easily with NGRX. There's a great blog post on implementing a Minesweeper game with Angular 2 and immutable.js. So you can picture Minesweeper, right? Every one of those mines is a component. So it becomes very important to not check the mines that didn't explode, but only the mines that could have exploded. Here's a link to the downgrade module. This is actually the unit tests for downgrade module, because we don't have docs yet, but it shows you how to use it. And this is the PR for the documentation for downgrade module. So that's it. Any questions? Okay. All right. Thank you.